So welcome everybody to our Bringing the All-Flash Virtual SAN to the SMB webinar. This is Ryan Brown with xByte Technologies. A couple of housekeeping items real quick. If on your screen, if you do have the GoToWebinar window covering up anything, there's I believe it's an orange colored arrow pointing to the right. If you go ahead and click on that, it'll get your GoToWebinar out of the way, and then you can go ahead and see any of the slides. If you have any questions during the webinar, please submit them. If you click on that same arrow bringing the GoToWebinar out, you'll be able to submit any questions to us, and we'll go ahead and tackle those at the end of our short presentation here. Also at the end, we'll be giving away the $50 gift card, so stay tuned for that. We'll pick someone random who's on the attendee list, and they will receive that $50 gift card, and we'll contact them afterwards to get that out. So again, thank you very much for coming. I'm Ryan Brown, xByte Technologies, talk about that. Getting into the agenda here, we'll talk about the all-flash benefits and new features, building the case for the all-flash vSAN, talk about how to get started with vSAN, then we'll talk about some current VMware promotions that xByte's doing, open to questions, and do that gift card giveaway that we talked about. Before we get into any of the presentation itself, I want to do a quick poll to get just a sense of how many of you guys are currently using any hyper-converged solution. So if you see on your screen there, the question is, are you currently using any hyper-converged solutions? So go ahead, and we'll give it about a minute for people to vote here, just so we have a good sense of in the audience where we stand. All right, we'll give it another 10 seconds here for anybody to kind of jump on here. And we'll go 3, 2, and 1. And so the results, if you're looking at that right now, it looks like there's a good amount of you that you're planning to implement something in the next few months, a good amount in the next year. 43% that no and no current plans. So hopefully by the end of this, we'll convert that 43% into one of the other buckets. So John, we have our work cut out for us on that 43%.
I like a challenge.
So let me go ahead and introduce our esteemed guest here, John Nicholson. He is VMware's Senior Technical Marketing Manager. You can read all of these the accolades on here and the certifications he's gone through. He is really Mr. vSAN. So we are very excited to have a chance to have him join us on this webinar and help talk about the all-flash vSAN. So let me go ahead and at this point, let me go ahead and John, I'm going to pass the ball over to you, and you can walk through the vSAN.
All right, taking control here. Let's play from the start. Hide that. All right, again, as he said, my name is John Nicholson. I'm a Technical Marketing Manager in Storage and Availability. I'm primarily focused on vSAN, so let's get started. So the first thing, just a quick overview of what vSAN is before we get into the weeds here. Virtual SAN is a hyperconverged storage platform. It is built into vSphere. And so what this means is that if you have vSphere 5.5 Update 1 or newer, you actually already have vSAN. You already have the code installed. You just may not have licensed or configured it yet. This runs off of standard commodity x86 servers. We don't need any proprietary storage arrays here. And this basically pools and converges local storage and flash resources into a single shared data store that can deliver an enterprise-grade storage solution. Well, now, while you have a single data store, individual virtual machines can be managed on a policy level. So different virtual machines can have completely different characteristics of performance, maybe things like setting IOP reservations, or also various cache management policies and things like that. But this is deeply integrated and managed through vSphere, through existing tools and VMware APIs that you know and love. Now we have two different models for consumption of vSAN, we have the traditional hybrid, which we released in 5.5 Update 1, and it was good. It really was good. It's quite fast. That said, we had customers as flash came down in price, they started, looking for all flash. And when you look back at the early days, flash was rather expensive. So we kind of separated out the performance in the flash tier on hybrid from the backend capacity, which was based on magnetic disks. Now, what we're seeing really, though, is a transition to all flash for really all our new customer deployments. And the drive for this is a couple things. One, all flash delivers even better performance as well as consistent performance. There's no case to where you're moving from that flash down to the slower disk. You're just always in a flash world. And the other thing also is it drives down latency. And latency drives up customer expectations and performance from application. People click on things and they just instantly happen. I remember the first time I logged into a VDI farm that was powered by all-flash vSAN, and it was so incredibly fast. I groan anytime I log into a slow VDI environment or one that isn't powered by vSAN. So we've had now 5 releases. We had the original release, we had 6.0, we introduced all-flash, 64-node cluster support. 6.1, we introduced stretch clusters. So if you have 2 sites, you get a third witness and stretch that cluster between the sites. We also introduced better replications, native replication support. In 6.2, we also introduced some powerful features for data reduction, deduplication compression, RAID 5, as well as quality of service. And we also just announced 6.5 of VMware, and I'll get to that in a bit. So let's take a look at what 6.2 did to really drive all-flash vSAN adoption. So the first feature that we really wanted to get right was deduplication and compression. And this is a feature that if you've worked with on traditional storage arrays or traditional hybrid arrays in the past, there often were a lot of compromises. You had to schedule when dedupe would happen. You had different containers. This data set we're going to set compression on. This one we're going to dedupe, but only after hours. This one we're going to do inline compression. And I joke, you had to have a giant star chart to align the planets and figure out what was the proper way to not murder performance and introduce a little bit of space savings. And oftentimes, a lot of these storage systems, when they did deduplication, they would use a very large block in terms of pattern matching. Use a 16 kilobyte, and really all you'd find for duplicate data with that was just your operating system binaries. It really did not save that much space. It was a headache, and it caused a lot of problems on controllers. And we wanted to implement deduplication compression to where it did not involve all that operational complexity. And we looked at it, we could have designed it for hybrid, but it just would have come with too many challenges and too many trade-offs. In that regards, we decided to double down on all flash. And so we designed this to be the best deduplication compression engine we could build for all flash. So a couple things we did was we chose a 4 kilobyte fixed block, which is very granular. You're going to find lots of space savings. We're using a SHA-1 hash for doing that pattern matching. And then on the compression, we used LZ4, which is wicked fast, amazing at compressing data down. And we wanted to make this very simple. So when you turn this on for your virtual SAN cluster, it's just a single checkbox. You enable it when you build out your cluster at the start, and it's just baked in, and you're done. Now let's talk about how we accomplish that without significant overheads or problems that traditionally come from an inline type process. So one thing we did is we did not want this to introduce latency or significant performance challenges. And so what we do is the data is actually written fully hydrated to the write buffer. So in all-flash vSAN, you have 2 different types of flash. You have a high-endurance write buffer flash that has really low latency write performance. And then behind that, we have our lower-cost capacity flash, which is much cheaper, but is not going to deliver very consistent write performance. So that initial write buffer, which is typically about 10%, that's going to acknowledge that write fully hydrated, nothing in that I/O path, and then at that point, the virtual machine, it's done with its write, it continues with its stay. Now, on the back end, data would always naturally trickle from our write buffer back to our capacity tier. And this is a movement that the data, it's inline, it was already going to be making that movement. This is where we do the duplication compression. And again, as I mentioned, one, we didn't want to slow down that initial write and that acknowledgement to the VM. But also, another thing to keep in mind is a lot of writes have a very short lifespan. They have a lifespan of a gnat. If our data comes into that write buffer and it quickly is overridden, we're not going to waste CPU compressing and deduplicating that data if it's just not going to live very long. So what we do is, again, we acknowledge that write, and then we begin that process. And the first step we do is we look for duplicate data. And this data, at this point, it's in memory. It was already going to be in memory because there was a migration an inline migration from the write buffer back to the capacity tier. So we're going to run a SHA-1 hash. If it matches, great. That means we have duplicate data. We're not going to waste compute on compression. We're just going to write a pointer and be done with it. If the data is actually unique, if this is unique data that we've never seen before, we're going to compress it. And when we compress it, we're going to run that LZ4, which, as I said, is very efficient. I mean, this is highly optimized. And again, SHA-1 and LZ4, Intel has done a great job of making great optimizations for. Now, when we compress that data, we're going to see how well it compresses. If that data does not compress well, if it's uncompressible encrypted data, we're actually going to write it fully hydrated because we don't want to waste CPU rehydrating compressed data that doesn't compress well. So we actually do a check there. And so all of these checks, not deduplicating data that has a short lifespan, not compressing data that's duplicate, and not rehydrating data that compresses poorly. All of these things come together to where the added extra compute overhead we typically see is only about an extra 5% to turn this feature on, which is really low. And for anyone who's not doing, sending, large amounts of uncompressible or unduplicated data, this is going to be a pretty simple no-brainer. Check that box, turn it on, and move on with life for your AllFlash vSAN. So again, showing how this is set up, here's your vSAN setup screen. In this case, we're going to go through manually claiming our disks and identifying which disks are the right buffer and which are capacity. Deduplication, there's end compression, single feature, there's your checkbox. And then down at the bottom, we decide, is this a stretch cluster, is this a 2-node? We'll talk a little bit more about that, or a fault domain even, which is my favorite. Fault domains where you split vSAN across multiple cabinets or areas of a data center pods, and so that way you can tolerate different failures. So again, as I said, best practices is you're just going to turn this thing on, do it at the beginning, and then away you go. The other feature that really helps drive down the cost of AllFlash, and again, this was something that we looked at with hybrid, and we looked at some ways to implement it, but again, it came with a lot of compromises, was doing distributed RAID 5 and RAID 6, also called erasure coding. On the RAID 5, we're using a 3+1 construct. And so what this means is from an overhead standpoint, is traditionally with vSAN we use mirroring. So a 20 gigabyte virtual machine would use 40 gigabytes of space. Instead, with RAID 5, we're now only consuming 27 gigabytes, which is very low. And this RAID 5 is split across, it's going to stripe across the hosts in that regard. And then also we've got RAID 6, which operates on a 4+2 construct. Previously, we would have to mirror twice with using the basic RAID 1 protection on hybrid vSAN. With RAID 6 here, we only have 30 gigabytes of overhead instead of 60 gigabytes, which is amazing in terms of efficiency. And by the way, RAID 5 and RAID 6 can be combined with deduplication and compression. RAID 5 and RAID 6 are unique in that they're managed by our policy engine. So these can be applied as granular as an individual VMDK or individual object. So maybe you had a log volume that's super heavy on writes and you wanted to still keep this RAID 1, you could do that while still having the database volume be a RAID 5 or RAID 6. You can mix and match that, and these policies can be changed on the fly, and the vSAN object system will re-mirror and slide data around as necessary to deliver that. The other thing I like about RAID 5 and RAID 6 is even if you have data that doesn't compress well, or maybe you have encrypted data, this is savings you can bank on. You know the savings are going to happen versus the traditional mirroring, and they're going to deliver, and that's a really great thing. Some people ask, why not try to deliver this on hybrid? The challenge is that from a rebuild overhead perspective, whenever you have a damaged stripe in a RAID 5 or RAID 6, which is what happens when one copy of parity or data is missing, you have to read that entire row. So it actually causes significant read amplification when you're doing a rebuild. Now, when I'm dealing with solid-state drives that can deliver 40,000, 100,000 operations a second, that amplification is not a huge deal. If I'm dealing with a traditional 10,000 RPM drive that only has 200 operations per second it's capable of, if I'm getting an amplification of 4x, that can be pretty brutal. And so we didn't want you to have a situation where you're running a system that runs all right until a rebuild, and then you're missing SLAs, applications are timing out. We wanted these features to be able to be enabled without compromise and without, again, having to consult star charts. So RAID 5 and RAID 6, we optimized it for flash in this regard to where they're ready to roll. Now, we also wanted to add some reporting features in, so you can actually see within the UI and see how much space you're saving in the environment, and look at the savings, as well as also see where space is going. Maybe you have a lot of space going to swap for memory reservations and things like that. We want to have a holistic view, because traditionally from your storage array, it's not really aware of what's going on inside the VMs. and where that actual data is going. Is this for overhead for performance management database? Is this actually related to virtual disks? Where is my space actually going? This gives you ability to rapidly see what's going on with your data. Now, getting back to AllFlash, the question comes, well, what about, my traditional fast disks? It used to be Flash was your tier 0, then your tier 1 would be a 15,000 or a 10,000 RPM drive. And really, when we looked at implementing these features a year ago, 15,000 RPM drives were already dead, effectively. They were not worth, in order to get adequate performance from them, you'd have to deploy 100 of them to match an SSD. And at that point, it just didn't really make sense. And even from a cost basis, Flash was already coming close on capacity. 10,000 RPM drives are at that point now to where they really just can't deliver. As they get bigger, they're not delivering additional performance, and the cost basis just doesn't line up. And when we look at mirroring with 10 or 15,000 RPM drives versus doing a distributed RAID 5 or RAID 6, we find that really going all flash with these extra features really drives down cost. And again, when you go to RAID 6, which is our ability to tolerate at least 2 failures or 2 hosts, triple mirroring was always a very expensive proposition, even with nearline SAS drives. So the other thing is to look at the price of flash, and I have this chart here to illustrate, the price trend of a 10,000 RPM drive and flash over the same time period. Flash has been rapidly falling. And the fact is, this has been driven by advances, 3D NAND, things like that. And actually, as we go into the back half of the year here, additional foundries are bringing on additional 3D NAND capacities. This price is still going to fall. What's happened in flash prices in the past 2 years is going to be a sustainable trend for a bit of time. There were some concerns that we weren't going to be able to, we were going to hit a peak number of layers within 3D NAND flash. But actually, they found ways to sandwich it. It's kind of cool. And that they've been able to just keep stacking layers. We're going 96 deep and deeper. The other thing is, as NAND evolves, we're also seeing that there's limits to what we can do with it long term. But there's new classes of persistent memory, things like 3D Crosspoint that are coming out. And these will, again, put downward pressure on NAND. When flash is no longer the cheapest option, and you now have persistent memory, NVDEMS, 3D Crosspoint, it's naturally going to become much like how nearline SAS drives became, or 7200 RPM drives became very cheap. Flash is going to feel that same downward pressure. The other thing is we're also seeing in trends in terms of lowering prices. One new concept is NVME, which is a new interface that allows you to expose a direct PCIe type connection and also bypass the legacy SAS and SATA infrastructure. SAS and SATA were never designed for flash. And NVMe is going to help us deliver, instead of having a single I/O queue, we can now have 4 million possible queues. Instead of that queue being only 32 commands deep, it's now 4 million commands deep. We're going to be able to really start to extract better use of the performance that flash is capable of. Also, this is going to lower cost and complexity by removing things like RAID controllers and SAS expanders. Lowering the number of chips and the number of things in the I/O path not only increases your cost value proposition, but also increases resiliency, just because there's fewer cooks in the kitchen, so to speak, in your I/O path. The other thing is flash previously, even though it was falling, some of the server manufacturers were kind of holding on to really high prices. That's really flipped. If you go to Dell.com, even you're gonna see a capacity-based flash device for close to 50 cents in the U.S. And it's the OEMs are actually, you're seeing that the 10,000 RPM drives, their price is actually stagnating while flash is continuing to fall. And we're seeing just the death of disk. If you look at Seagate, some of the announcements, these guys are actually shrinking their footprint that's out there in terms of their disk manufacturing. They're buying flash vendors, Western Digital, I believe, bought SanDisk and so forth. So we're seeing that flash is really the future. And while disk, we really are down to 2 major vendors. With flash, we still have 4 major foundry operations going. And so there's a lot of different technology, a lot of different breakthroughs that are coming. Some stuff under NDA that's coming. It's really exciting. So when we look at the scenario of a hard drive versus solid state drives, we're looking at a 10,000 RPM drive, and this was some prices pulled fairly recently. Standard Dell servers, standard discounts, things like that. No funny numbers here. What we discover is that comparing failure to tolerate a 1, a distributed RAID 5 versus the mirroring overhead, it takes very little amount, just about 1.2x deduplication before suddenly the all-flash is faster. And the all-flash is also going to be a lot, not faster, but also cheaper in this case. And we're also seeing that our usable cost per gigabyte very rapidly drops down And this is all in. This usable cost includes the cost of servers and things like that. But our usable cost per gigabyte is falling below $1, and that's including compute. So you're getting to run VMs with that. This isn't your normal, here's my price for my storage array per gigabyte, where all it does is serve disk. This is running VMs, and that's part of the value proposition of vSAN, is as you expand it, you're also adding the ability to run more virtual machines. Now, some people ask, what about nearline SAS drives? Those big, slow 7,200 RPM drives, and could we use those for hybrid and drag the hybrid story out longer? There are some people that they are cheaper still from a cost per gigabyte, but there's a problem with them. They keep getting bigger, but as they get bigger, they effectively get slower because they still have the same amount of in-out operations per second they can deliver, and as they get bigger, the IOP, in-out operations per second, to gigabyte density factor basically gets cut in half. This is like having the same amount of horsepower and doubling the weight of your car. Yes, you were able to double the amount of things on it, but it's just going to get slower and slower and slower. And for workloads that have any latency sensitivity, or they're not 100%, you can fit within that cache layer, you're increasingly going to be like it's going to be like you've got a Ferrari and you're going 200 miles an hour, and then somebody downshifts into second gear on you. It's just jarring when you have that few amount of IOPS on the back end for performance. And they also, these larger drives, as they get bigger and bigger, trying to resynchronize between hosts and do rebuilds and things like that, there's just not a lot of spare horsepower there, so to speak. No, we're still committed to hybrid for existing customers, and we're delivering new features and things like that, like the new iSCSI that came out in 6.5. So we're not killing hybrid, but naturally the market forces are shifting it to where 80–90% of the new quotes I'm seeing going out are really about AllFlash. One feature I did want to talk about that really helps for small environments is 2-node that we introduced back in 6.1, which is a great solution. What this is we have 2 nodes for vSAN that have local disk, and then we have a remote site of witness. Now, one of the challenges for this, though, is you got those sites that got a little bit bigger, is you often wanted to go from 1 gig to 10 gig on your networking for vSAN and for vMotion. But 10 gig is expensive for switching. The NICs are cheap. In fact, they're often built into the servers. But with the switching being a more expensive component, people didn't want to spend $10,000 on switching for a site where they had, maybe $4,000 for the servers. It's kind of out of line. So in 6.5, we introduced the capability to separate the witness traffic to a different VM kernel port, a different network port. So what this allows you to do is to run your witness back at the main data center and use 2 10 gig connections, or you could use 40 or 100 if you have them, and directly connect those vSAN hosts. So now you're getting full 10 gig for your I/O path, for resyncs, you're avoiding switching latency overheads, and you're also getting 10 gig or you're faster for vMotion. So that way when you do maintenance on these remote hosts. And this can be combined with our Robo licensing pack, which was really awesome. This allows you to buy a 25 pack of VMs. So if you got a lot of little sites with 1 or 2 VMs, you can now build an HA cluster, full bill of materials, AllFlash, getting a pair of Dell Tower servers, modest. With the licensing, since you're paying per VM now for both vSphere and vSAN and the servers, I've seen this $10,000 actually be an attainable price point, which is pretty amazing to be able to deliver a small high availability solution with 10 gig performance at $10,000 all-in software hardware. So we're really cutting the traditional cost to deploy a small remote HA cluster in half, or even probably more than that. So that's something that came in 6.5. We're really excited to announce. We also have iSCSI. We can work on physical servers, expose data outside the cluster. But this is something that's going to drive a lot of adoption for people who've got a lot of small sites. So at this point, I want to hand this off to Ryan. And then after, hello? Let's see.
Yeah, I'm here. I'm taking control back.
Oh, there you go. So we'll have Ryan talk about some promotions, and then we'll have some Q&A. So if you guys have questions about AllFlash, vSAN, or 2-node, I'm more than happy to help with those.
Okay. All right. So a little piece of it, John had talked about how the pricing is really come in line with the death of the 15K. So just this morning in prepping for this webinar, I went out to Dell site, went to their Dell R630 page, and wanted to pull in current pricing just to get an idea of, okay, is what John's saying accurate? Is the price point really that close to each other? And these are screenshots from Dell site, of course, without the highlighting, of course. But on Dell site, you can see in the upper drive, the 615K 12 gig per second at $657. When you look down at the second piece of it, the 800 gig solid state drive, the Intel S3610 is at $619. Even going to the more write-intensive S3710, the second one highlighted, that's only $750. So your per gig price is less expensive going with solid state drives, and that really hammers home the point that John was talking about, is that these OEMs are really cutting the prices of the solid states to make it a no-brainer to go solid state. I didn't highlight it, but I would bet if you did the math, looking at the 600 gig 10K drive right above the 15K at $335, given the benefits you can get on the RAID 5 compared to RAID 10, you could actually make the case that it makes more sense to go with solid states versus even the 10K drive. And purely on a price point level, not even thinking about the performance benefits that you gain with AllFlash. Let me go ahead and go. Just to kind of wrap things all together and how xByte plays in all this. At xByte, we do it all. So easy server, storage, networking, software, warranty, support, service. What we help people with is that we give them the best options at the best price. So if you're looking for new servers, we have something for you. If you're looking for refurbished servers, we have something for you. Any of those options, we have, of course, all the parts in place. And then we layer into that great relationships with our software manufacturers. So if you're looking at VMware, we have John or anyone on that team. We're high enough partners that we can get you involved in the right people. We also have experts on hand ourselves. So we have 2 VMware certified professionals on staff, plus access to any of the VMware staff we need to answer any questions. Where Veeam partners can kind of also get that combination. A lot of people use that for their backups. So we really kind of bring together the best prices with the best access to support both pre and post sales. And adding in a really white glove service that you're not going to find really anywhere else. So that's where xByte kind of falls in line with all of this. And let me kind of show you guys a few of our promotions going on right now. So the promotions we have, if you buy 3 single CPU all-flash servers with VMware Advanced and a 10 gig switch, you get a free upgrade to 1-year production support on that whole package. And you can read the other ones as well. So we're really trying to work with people as they're looking to implement vSAN or VMware in general, and putting together some good promotions to help make that happen for them. I'll go ahead and I'll leave this up there for a second, just in case anyone's taking any notes. Hopefully many of you are. All right, and we'll go ahead and go into questions here. And let me go. And the first one is a housekeeping question. And John, if you see any questions you want to go ahead and grab as you're looking through the list, go ahead and grab them. A couple of people asked, will the slide deck be available after the presentation? And to answer the question is the whole presentation, including any of these questions, including our commentary, will be available on xByte's YouTube channel after the presentation, and you'll get an email with the instructions on how to find that. And let's see here. And just housekeeping as well, if you do have any questions, if you've gotten rid of the GoToWebinar screen, slide it out with the orange arrow, then you can go to your question section and go ahead and send those in if you haven't already done so. John, I got a question for you. It appears as though vSAN allows for tiered storage, cache then to disk. Is it possible to have another tier for larger, slower mechanical disks for bulk storage and have older data age out to the lower tiers?
So how vSAN works is it's not a tiering, it's a caching system. The reason for this is tiering has a lot of challenges from performance consistency. Tiering typically works on a schedule, and also tiering has a tendency to move data back and forth in large chunks. Our caching is very granular. We're using a 4K block for our writes coming in and out, as well as we have 1 MB buckets. So from getting the most bang out of your flash, cache is a lot better solution. So that's the solution we chose. And so that even on the AllFlash, that write buffer, that data is not going to live there permanently. Now that said, if you had an old, you had your legacy storage environment or legacy storage array in the environment, you could always use vVols, which is our virtual volume technology, and mount that old slow magnetic storage in there, and then use technologies like StorageGRS to promote data off, as well as also that would extend the vSAN SPBM storage-based policy management engine to that bulk slow, archive storage. But vSAN is really designed for your transactional, your day-to-day VMs. And increasingly what we're seeing is for anything that's not just a bulk cold storage environment, Flash just makes really all the sense in the world.
All right, another question for John. Why for SMB, why a 2-node versus a 3-node or even a 4-node cluster?
Good question. So, or even a 5. So there's different benefits to different numbers. 2-node requires a witness to operate, and that witness needs to be separated from a fault domain. So, because obviously, if one node and the witness goes down, you'd lose quorum, and everything would have to power off. 3 nodes is the minimum without a witness. 4 nodes is the minimum for RAID 5, and or if you're using traditional mirroring still instead of RAID 5, 4 nodes also has an advantage with mirroring in that you can have a host fail, and then assuming you've made sure to reserve plenty of spare capacity, the 3 nodes can rebuild and repair amongst themselves. You'll still have quorum even after a host failure. So that's one benefit to 4 nodes itself. 5 would give you that same benefit of being able to tolerate a failure and rebuild in place with RAID 5. So those are your benefits and trade-offs of 2, 3, 4, and 5.
Now I have a question for you, and you and I were talking about this earlier, is that one of the changes in 6.5 was with the licensing. And if you can kind of elaborate a little bit on that, on the licensing for AllFlash.
This is something I'm very passionate about because I've been yelling for the past year trying to get this fixed. So although we generally only make pricing changes around VMworld once a year. So previously, if you were using AllFlash without the space efficiency features, maybe it was a small site, you could just, as you said, Flash is getting so cheap. You just wanted to do basic mirroring. Previously, we would force you to buy the vSAN Advanced license. We were basically taxing you for just the fact that you happen to be using Flash, which wasn't very nice in my opinion. So that's been cleared up, that's been fixed. Now you can use AllFlash on both the Robo as well as the standard license, assuming you're not using the deduplication compression or RAID 5. Now, if you have any significant amount of data, those features are probably going to net you some pretty good savings. But if you got a really small site, Flash is pretty cheap. You might just be able to get away with standard.
So in our promotion, just to kind of tout a little bit of promotion, we did put the advanced in there thinking that people were going to go with the dedupe compression and RAID 5. So that's why we kind of went with that. But we can always work with you if you want something else. We're very flexible.
And yeah, the advanced, it's not that much more really at the end of the day. So, but that's the great thing is there's a lot of different ways to consume vSAN. As I mentioned, we've got the Robo, where you buy the 25 pack that you can spread across multiple sites. The traditional licensing is per socket, so you keep buying flash drives as they get cheaper, and we don't ask any more money from you. Once you've paid for that server, if you have spare drive bays, you can just keep buying some more drives from xByte here and keep growing and leverage that incredible downward price trend. The other way we license, if you're buying for VDI, we license per user. So that way, if you add another host, just because you need another 20 users, we're not going to make you pay for a full, all the amount of licensing that would be required to use the maximum capacity of that host. And if you happen to be a service provider under the vCAN program, you can pay per consumed capacity, and that's to align with how you bill your customers for hosting. So lots of different ways to buy vSAN that all kind of align with basically the value we're delivering.
All right, here's a question that looks like kind of in the same same form of the Y2, 3, or 4 node, but how many ESXi hosts do you need to get vSAN working?
The absolute bare minimum is 2 hosts and a witness stored not on those 2 hosts. That witness can either be a physical bare metal ESXi or it can be a virtual machine running on a host somewhere else. If you want to have a full standalone with no witness, it would be 3 would be the minimum.
All right, John, I think someone may be trying to stalk you, but the question is, are you going to be at Spiceworks or Spice World?
I will be at Spice World next week. Yes, next week. I will be there. I'm flying in Tuesday, and I'm flying out Friday. So I'll be there all week. Come find me. You'll find me at the conference. You'll find me probably on 6th Street at some point. And let's talk storage. Let's talk virtualization. One other pricing thing I wanted to mention, and I'm sure xByte can work with you on this, is as we're licensed primarily per socket for server workloads, if you've got a real small environment, go single socket. You can get some pretty big, beefy CPUs that way, and that way you can cut your vSAN licensing in half. It's a little secret tip I'll pass on.
Now, I recently heard that Microsoft was changing their licensing to per core.
I think they're taking the Oracle approach to deliver less, charge more, but, that works for them.
Didn't you guys do that a couple years ago?
We tried to charge for RAM like 3 years back. That was an interesting decision, and the appropriate people I think were relocated to the frosty north. So,
well, apparently Microsoft has not learned from those examples.
From what I've seen in terms of that core shift, it's going to basically increase costs by a factor of about 2.5, assuming you're buying modern processors. So. We like to deliver, but that's the great thing about per socket is you buy vSAN, you buy a socket license for a host. Maybe you fill out half the drive bays initially, and then you wait and you add the other drives later. And since you're buying regular server drives, they go down in cost. A traditional storage array, if you go to expand it later, all those upfront discounts are gone away. It actually gets more expensive. It defies the laws of commodities and actually physics. I like to say we're the good guys in storage. We're not going to try to charge you more for a commodity that's decreasing in pricing. The only people I know can get away with that, they work in some unsavory industries.
All right, here's a question that either of us can really take. Why buy now if SSD prices are going to continue to fall? I'll let you take this, and I have an answer for it as well.
Well, so first off, you may just have things that need to be done today. If you have users that have slow application performance and you've got a storage array coming up on renewal, you may just have to buy something today. But the key thing is vSAN, you can add it 1 drive at a time. You just buy 1 drive for each host and just expand those disk groups out. So, if you want to take a more just-in-time provisioning, most people like to make sure they've got a year's worth of capacity up front, but you don't need to, the traditional storage model of buy 5 years or 3 years of storage up front, I completely agree with you. You don't need to do that anymore. So maybe you buy 2 disk groups in each host. Maybe you've got an R730 type platform, and you've got 12 of the 24 drive bays populated, and then you wait 18 months down the road. You go buy the other 2 disk groups when you actually need the extra capacity.
Yeah, from what I've seen, all IT prices drop. So making the decision to buy now is really more of a business decision. So will it save your business money right now, and will it or increase your productivity, increase your efficiency, any of that? Then it makes sense. Later on, it'd be even more of a case as prices drop. But the same thing you see in CPU prices. The 8-core processors today are the same price as the dual-core processors of years back. So you're always going to have the technology decreasing. So it's more of a business decision than a necessary am I going to take a chance on a price going down later. But to John's point, unlike traditional storage, you're not buying for the next 3 years up front.
Well, the other fact here is that traditional storage array, when you come up on the end of support renewals, or they become too expensive, you're basically throwing away that investment. With virtual SAN, this licensing is perpetual. As long as you pay your support renewals, you actually get free upgrades for life, which is pretty awesome, as opposed to your traditional storage system to where you spend a lot of money on something that had its 3 or 5 year run, and then it's out of support, it goes in the dumpster, it's junk. Virtual SAN, we're evolving constantly. We were the first software-defined storage platform really to properly leverage NVMe by a good year. And we're already looking at the new technologies, persistent memory, things like that. So while the hardware underneath may become old and comparably slow in the future, you can leverage this licensing investment you make now as new, denser, cheaper, faster, more awesome flash technologies or persistent memory, let's call it what it is, come out. Good question.
All right, we'll go ahead and if you do have any questions, I'm going to give it another 15 seconds for you to kind of write those in. I believe we got to everybody. If you do have any questions after this, you can always, if you happen to be someone attending Spiceworks, you can hit up. Actually, John mentioned he's going to be there. xByte will also be there. You can come check out our booth. I forget what our marketers called it, but I call it our wheel of torture, where you get to spin and either choose to build a server by jumping on one leg, eating a puke-flavored jelly bean, or doing things like reciting the alphabet backwards as you build your server. But it's all in good fun and a chance to win $300 in the coveted xByte Server Build Challenge trophy. So it should be a fun time. Looking for any other existing questions? No. I'm going to flash up on the screen our promotions real quick, just in case anyone want to take a look at those. And as John mentioned, the single CPU. So our promotion, we did want to push on the single CPU to save everybody on their VMware licensing, and also put in the advanced product there to allow them to make use of the RAID 5 and some of the new features of compression and dedupe in their vSAN technology. So yeah, if you're happen to be going to Spiceworks, catch us there. You can also hit us up either online. We're both actually active in many forums out there. You can hit xbyte.com is our website. John, I don't know if you have any good ways to reach you.
Yeah, so you can find me on Twitter at @lost_signal. The Virtually Speaking podcast is a podcast I do weekly. We've got some great guests across storage and virtualization. We're bringing on, just had Frank Denneman talk about the new vSAN AWS or VMware AWS announcement. And then also you can find all your documentation and frequently asked questions can be found on storagehub.vmware.com. That's storagehub.vmware.com. So.
All right, well, John, thank you very much for joining us. It's very informative, and I hope all those SMBs on the line. I hope those 43% that we saw where they were not planning any vSAN deployments in the next 12 months that we've converted some of those at least to taking a look at it over the next year.
I think we made progress. So, all right, thank you guys.
All right, thank you guys.